Okay, so we're going to continue on with some of our circuit analysis here. Now really these next couple of videos are just going to be a couple example problems because we're just going to basically apply circuit analysis techniques, and I need to get something here quickly. Apply circuit analysis techniques to solve steady state problems. Now in some cases we're going to have to find the actual impedances. Sometimes the problem will give us impedances. So let's look at this first one here. So this first problem is find the Thevenin equivalent circuit. And so the circuit that is given in this problem is the following. So the capacitor is minus J30, we have a 15 ohm resistor, and then a J30 ohm inductor. So this is the circuit I'm looking at, and I want the Thevenin, and then it's got 180 at an angle of 90 degrees. Well, as I said, I prefer to do things in rectangular format, so I'm going to convert this 180 to rectangular, which would be 180 J180 volts, because again, you want to get in this habit of being able to look at things that are at 90-degree angles and get it right away. So if we look at this, 90 degrees would put you on the positive imaginary axis, and then of course you'd have the point here of just 180. So this would be of course J180 because it's on the positive imaginary axis. Alright, everything's in rectangular form here. Now we just do regular analysis here, and remember this plus minus V open circuit is equal to V Thevenin. Now there's two ways to approach this problem to figure out what V open circuit is. Honestly, the easiest way I think to do this is simply just doing voltage division, because if we think about this, let me just even draw these in here. We could do a nodal analysis, but if we look at here, these are all currents, and I'll say like I1, I2, and then I3. We know that I3 is equal to 0 because there can't be any current going through that capacitor because it's an open circuit. So as far as computing voltages, there's no voltage across that capacitor. And so then that also means that these current I1 and I2 are just opposite each other. And so we could use voltage division. And so using voltage division, we get that V Thevenin is equal to 15 ohms over 15 ohms plus J30 times J180. So now we just have to do that computation, and we get 72 plus J36. Now, it's okay to have it in rectangular or polar form. It doesn't specify what we have here, and again I should put units here, this is volts. But if I converted that to polar form, just using my calculator real quickly, you'd get 80.5 at an angle of 26.6 degrees volts. And again, this is just in polar form. So it's okay to have, whoops, I don't know what I'm doing there. It's okay to have it in either form, polar or rectangular. So doesn't really matter. I'll probably leave it in rectangular form. Now there is another way you could have done this. You could have again used those currents here where you have that, I1 plus I2 plus I3 equals 0, and then I1 would be some voltage, I'll just say VA over J30 plus VA over 15 plus 0, which then is equal to 0. Actually, I just had that equation wrong here. This shouldn't just be VA. It should be VA minus J90. Because if we go back to here, this would be VA right here minus J180. I can't even get my numbers correct here. Apologize about that. J180. VA minus J180 over J30. Because again, VA minus J180 over J30 plus VA over 15, and then this is 0. But again, when you have that current 0, we know then that VA equals V open circuit, and then you could just ... and then you'd get VA is equal to 72 plus J36 volts. So you can get it the same way either way. Now, we also have to find ZEQ. But remember, because all we have here are independent power supplies, when we were dealing with resistors, we would just turn off the independent power supply and find the equivalent resistance. Well, it's going to be the exact same for the Thevenin. All we're going to do is turn off that voltage source, and so we wind up with this J30 15 ohm minus J30, and then we have to find ZEQ. Now, remember, if you look at this circuit, this J30, let's put ohms here, this is in parallel with the 15 ohm resistor. So we should do that computation first, and you can do it several different ways. You can do the 1 over business, or because it's just simply 2, we can also write it as J30 times 15 over 15 plus J30, which I'll just quickly do that computation here. If I do that computation, I wind up with 12 plus J6 ohms. And so we'd have then a little box here, 12 plus J6, and then we have ZEQ still looking in, and this would be still my minus J30 ohm capacitor. And of course these are in series now, so I get a ZEQ of 12 minus 24J ohms. So then of course we should always draw my Thevenin equivalent circuit. So the voltage source, remember I said we could have it in either polar or in rectangular, so I'm going to write it in rectangular. So this is 72 plus J36 volts. And then for the ZEQ, again, we want to draw the circuit elements that make up ZEQ. So we have a 12 ohm resistor and a minus J24 ohm capacitor. So that's what we'd end up having.